All right, so in the software world, we usually think about communication like it's a direct phone call, right? But what if I told you the secret to building these massive, scalable systems wasn't a phone call at all, but more like sending a letter? Today, we're going to dive into the postal service of APIs, the messaging style, and see how it can totally change the game for how our apps talk to each other.
So just think about your standard client-server setup. It's basically a phone call. One app calls another, and then it just sits there, waiting for an answer. That's synchronous communication. And honestly, it's the backbone of most of the digital world. System A needs info from System B, so it dials it up. Seems simple enough, but, what happens if System B is busy or just doesn't pick up the phone?
And that's the big problem, right? System A is completely stuck. It's on hold, totally frozen, can't do anything else until System B finally gets back to it. So if System B is slow or swamped with requests, or maybe just flat out broken, System A is just left hanging. This constant waiting, it's a huge bottleneck. It makes our systems incredibly fragile.
Okay, so what if we could just break that dependency? Imagine if our applications could just fire off a message, like dropping a letter in a mailbox, and then immediately get back to doing other useful work, totally confident that the message is going to get delivered eventually. That, right there, is the big, powerful idea behind the messaging API style.
So how do we solve this whole waiting problem? Well, we use a middleman. It's a piece of software we call a message broker. And you can think of it as the central post office for your entire system. Seriously, it's a complete game changer.
So let's get specific. What is messaging, really? At its core, it's just a way for different applications to send data to each other in these little self-contained packages called messages. But the magic word here is asynchronous. The sender just sends the message and moves on. It trusts the broker to take care of the delivery. No more waiting.
This image here, it shows it perfectly. This is what we call message-oriented middleware, or MOM for short. See over on the left, you've got your producers. They're the ones sending messages. On the right, you've got your consumers who receive them. And right in the middle, that's our broker. Now, the most important thing to see here is that the producers and consumers never talk directly. Not ever. Everything, and I mean everything, goes through that broker. That's what we call loose coupling, and it's the secret sauce that lets our systems scale up and change without breaking each other.
And that whole postal service analogy really makes this super clear. The producer? That's you dropping a letter in the mail. The consumer is the person checking their mailbox later. And the broker? Well, that's the entire post office infrastructure that makes sure your letter actually gets there.
Okay, so we know who the players are. Now let's talk about the playbook. We're going to look at some really common battle-tested messaging patterns that solve actual real-world problems you're likely to face.
All right, first problem. Let's say you have a massive amount of work to get done. I'm talking like processing thousands of images or something. One single worker would take forever. You obviously need a whole team, and you need a smart way to hand out the work so it gets done fast.
And the solution for that is the work queue pattern. It's super simple. The producer just drops every task into a single line, a queue. The broker then acts like a manager, handing out tasks one by one to a whole pool of workers. The key here, though, is that the workers are competing. Any given task is only picked up and handled by one worker. And this is awesome because it makes scaling up a breeze. Need to go faster? Just add more workers to the pool. That's it. Okay, next scenario. What happens when something important happens, like a brand new user signs up for your service? This isn't a task for just one worker. This is an event. It's news. And a bunch of different parts of your system probably need to know about it right away.
This is where the publish-subscribe pattern, or pub-sub as you'll always hear it called, comes into play. The producer publishes a message to a specific channel, or topic. The broker then acts like a broadcast station, sending a copy of that exact message to every single system that's subscribed to that topic. It's a one-to-many deal. One message goes in, and many copies go out.
But what if just blasting a message out to everyone is a little too noisy? What if your billing system only cares about signups from Europe, but your analytics team only cares about ones from Asia? We need a smarter, more targeted way to send these messages.
And for that, we have the topics pattern. Think of it as a much smarter version of pub/sub. The producer tags each message with a routing key, something descriptive like signups.europe.new. Then consumers can subscribe to patterns. Maybe something like signups.europe.star to get all European signups. The broker is smart enough to match these patterns and only routes the messages to the consumers who are actually interested. It's incredibly powerful for building really complex event-driven systems.
Now, messaging sounds amazing, and it is, but it is not a silver bullet. It's not the right answer for every single problem. Like any big architectural choice, it's got its pros and cons. So let's get real and talk about both the good and the bad.
Okay, on the plus side, the benefits are huge. You get amazing scalability and resilience. Since all your services are separate, you can scale them up or down independently. If one of your consumer services crashes, no big deal. The messages just pile up safely in the queue, waiting for it to come back online. But the downsides are just as real. For one, you've just added a whole new complex piece of technology, the broker itself. That's something else you have to manage, monitor, and it can become a single point of failure if you're not careful. You also have to think about new kinds of problems. Like, what happens if a consumer grabs a message, processes it, but then crashes before it can say, "I'm done"? The broker might think it failed and deliver it again, creating a duplicate. And you can't always guarantee that messages will be processed in the exact order they were sent. You have to design your system to handle that.
So keeping all of that in mind, the big question is, when should you actually use messaging? When is it the right tool for the job? And when is that simple, direct phone call still the better choice? Well, messaging really shines anytime you're building systems with decoupled, asynchronous workflows. It is an absolute game changer for long-running tasks. Think about video conversion. Instead of making your user just stare at a spinning wheel, you can fire off a message to a worker and instantly tell the user, "Hey, we got it. We'll email you when it's done." That's a way better experience. It's also pretty much essential for modern microservices. We have all these little independent services that need to chat without being directly tied to each other. It's the total opposite of a synchronous style like REST, where you ask a question and you need an answer right now. If all you need is a simple request and reply, messaging's probably overkill. But if you're building for massive scale and you need your system to be resilient, it's pretty much indispensable.
You see, messaging is more than just a piece of tech. It's a fundamentally different way of thinking about communication in your software. It's about shifting from a world where you're shouting direct commands and then waiting around to a world where you're sending asynchronous messages and trusting the system to handle it. So as your own applications get bigger and more complex, maybe you should ask yourself, is it time to stop shouting and start messaging?